Okay, next up, I would like the Lewis structure for Bh3 and Ph3. Do the two molecules have the same electron group geometry? Do they share the same molecular shape? Okay, so let's start with Bh3. As usual, begin with your valence electrons. I have 3 from the hydrogen plus 3 from the boron. That gives me 6 electrons to play with. And so I'll have B as my central and then the 3 hydrogens. Right now I have 2, 4, 6, so the correct number of electrons. Formal charges, hydrogen each have 1 bond, so 1 electron in that bond. So that's 1 valence electron minus the 1 valence electron they have inside of that bond, so 0. Boron, it's going to be the 3 valence electrons it has minus the 3 electrons it's donated to each of these bonds, so 0, 2. And so my valence electrons are taken care of, my formal charge is taken care of. And so now I begin with the steric number. It will be 3 because I have 3 bonding pairs, no lone pairs, and this would indicate that it's trigonal planar. And so when I draw it out, it will look basically how I had drawn it before, with angles of 120 degrees between them. And both my E geometry will be trigonal planar. So the way the electrons are arranged around it and the way my actual groups are arranged around it. So the Bh3 molecule itself will also be trigonal planar. Let's check its polarity. So I have a dipole going in like that, one going in like that. So because boron is more electronegative than the 3 hydrogens, these two, their angular components will cancel, yielding only a vector pointing up that will be equal to the opposite one, so they will cancel, and the molecule will be non-polar. Next up, we're just going to do the same for Ph3. So my valence electrons, I will have 5 plus 3, so 8 electrons available to play with. So I can start with my 3 hydrogens, and I can see right now I have 2, 4, 6, so 2 more electrons left over. I'll place them on my central atom. Now when I come to the, if you want to check each of their formal charges, for hydrogen it is going to be the 1 valence electron minus the 1 electron that is partaking in this bond, so 0. For the phosphorus, it will be 5 valence electrons minus the 3 electrons partaking in this sharing minus the 2 electrons in the lone pair, giving me 0, 2. And so this is going to be our best structure. My steric number is going to be 3 plus the 1 lone pair, 4. Its notation will be AX3E. What that means is it will have an electronic geometry of tetrahedral, but a molecular geometry of trigonal pyramid. And so when I draw it, it will look like this. P with my 2 electrons, hydrogen, hydrogen, hydrogen. Now when I go about drawing the dipoles, I'll have a dipole pointing towards the lone pair. Hydrogen is less electronegative than phosphorus, and so I'll have those 3. Even if these 3 add up to 1, as they will, I'll have 2 different magnitude vectors pointing up. They can't cancel each other out. And so this molecule will be polar. And so let's come down here. Its electron geometry we found was tetrahedral. Its molecular geometry we found was trigonal pyramid. And last to be found that it will indeed be polar. So now let's go back to the questions asked. First up, we're asked if they have the same electron group geometry. Let me just zoom out so you can see everything. Okay, so electron group geometry, one is trigonal planar, one is tetrahedral. So the answer to Question A is no. B, do they have the same molecular shape? One is trigonal planar, the other one is trigonal pyramid. Those are two things. Trigonal planar is in the plane, so exactly as I've drawn it. Trigonal pyramid is more like a tripod. That's why I have one hydrogen going back, one coming out, and so it will look oh, it appears I have frozen, but it will look basically like a tripod. And so those two are obviously not the same thing. And so the answer to B is also no. The answer to C, we have already found. Bh3 is nonpolar, Ph3 is polar. So we have nonpolar for Bh3, polar for Ph3. And that's going to be it for this question.